Yeah, like
Yeah, we are live.
Okay, I'll start then. Hello and welcome everyone to the 34th lecture as part of our technical lecture series. Today we have a talk titled Exploring Speech Technology in the Context of AI Safety, and we are fortunate to have with us Dr. Jennifer Williams, who will be presenting this talk. Dr. Jennifer Williams is an assistant professor at the University of Southampton, where she is a PI and co PI on several large interdisciplinary projects, including voice anonymization, deepfake detection, public perceptions of speech technology, speech paralinguistics for medical applications, and AI regulation. She is also the South England Engagement Director and co-investigator on the new EPSRC National Edge AI Hub, which is a consortium of 12 universities in the UK. She completed her PhD at the University of Edinburgh on representation learning for speech signal disentanglement, while working part-time in industry on edge device voice recognition. She is chair of the ISCA Special Interest Group on Security and Privacy in Speech Communication and a member of the NIST-OSAC subcommittee on speaker recognition for forensic science. So, without any further ado, I'll hand the session over to Dr. Jennifer Williams.
Well, thank you very much for the introduction, and I hope that today's talk reaches a wide audience and piques people's interest. So the title of my talk is Exploring Speech Technology in the Context of AI Safety, and I'll talk a bit about what I mean by AI safety. So first, I want to give a recap of what things have changed since I started my PhD back in 2016. So in 2016, I was fairly certain that I was going to be doing my entire PhD on a particular type of speech synthesis called neural statistical parametric speech synthesis. That came out in 2016, and it was a really big deal. Then, as I progressed during my PhD, there were a lot of advances. So we had the language grounding problem. There was a lot of work done on that and cross-modal learning. Neural vocoders came out, and that changed the entire landscape of speech synthesis because they were able to create speech synthesis that sounded more natural and more human. We also had an advancement in speaker recognition with the invention of X vectors as well as style tokens. In 2018, the Voice Privacy Initiative began, and that changed, again, the landscape of speech synthesis as well as speaker recognition. And then there was a lot of advances in emotion recognition and paralinguistic analysis. The ASV spoofing speaker verification challenges continued to gain traction, as well as some new problems in spoofing called partial spoofing detection. And then we saw a lot of new types of neural networks that were multitask networks. So for example, being able to do speech enhancement and recognition at the same time, or speaker recognition and anti-spoofing at the same time. And now we're in 2024, and things have changed a lot in the last 8 years. So we have foundation models. ChatGPT has piqued the public curiosity. There are a proliferation of deepfakes that sound very convincing. And then there's been a lot of shifts in AI regulation. So here I'll play a clip of my friend, Gordon Ramsay, and here's what he has to say about my work.
Jennifer Williams, I mean, yeah, she is a great scientist. The UK is lucky to have her.
So that's very kind of him to say that. This was generated, this is a deepfake generated by Sync Labs. And this is a photo of Gordon Ramsay that has been animated with words that I have put into his mouth. So this is a deepfake, and they can be very convincing. In the context of AI safety, there's this global discussion happening right now, and there's questions about how autonomous systems will proliferate. Now, I have autonomous systems in quotations because autonomous can mean different things depending on the sector, but there's consensus that every aspect of our daily life and every single sector will be touched by artificial intelligence and these autonomous systems. A lot of people believe that they will make us more prosperous and more secure, but we also recognize that they will introduce new kinds of vulnerabilities and safety issues. Now, this is being recognized globally. There have been several safety summits, global safety summits. The first one took place in 2023 at Bletchley Park in the UK. A follow-on took place in Seoul this year, in May, and that was another collaboration with the UK and South Korea. Now, the EU AI Act has been passed, and they look to regulate any kind of unacceptable and high-risk applications. And even the US has joined in and done a Bill of Rights for artificial intelligence. So here are some photos from the AI safety summits. Now, the UK has taken a leading role in AI safety, and especially in collaboration with India. So the Foreign Commonwealth and Development Office, FCDO, has been collaborating very closely with India to set up some new institutes to benefit India. And there's also the US and UK AI Safety Institutes. So we're looking at sort of models of what these institutes will look like, how they will engage with industry, how they will engage with academics, and how they will engage with students. So there's this question of how will this massive effort, this massive global effort, work to protect the public, and how will it affect industry and academic researchers? So one way to look at it is that there are multiple different kinds of stakeholders with their interests in AI safety. So we have, for example, the general public, policymakers, standards bodies, the regulators. We have government and defense interests, economic sectors, academics like us, incoming students. So thinking about the next generation and who we're training up and what kind of skills they're going to have. And then, of course, we have industry and small and medium-sized enterprises. So a big question is, where is our work being represented in this global conversation? And this is a bit of an outline of my talk. So we'll look at whether or not AI safety is more of a threat or an opportunity, talk a bit about AI regulation, insights from voice privacy, and then a bit of what's next. So in the UK, we have this idea called Responsible Research Innovation, or RRI. And it is a lot more than just ticking a box and saying, yes, my research is responsible. It's actually a process that seeks to promote creativity and opportunities for science and innovation to ensure that they're socially desirable and that those research interests are undertaken in the public interest. To do this, we have to acknowledge the dilemmas, the ambiguities, the purpose, and the unpredictable impacts, good or bad. Now, there's different frameworks to perform responsible research innovation, and the University of Nottingham in the UK has come up with a deck of playing cards. They're the Responsible Research Innovation Prompts and Practice cards, and I have a photo of that in the upper right-hand side. Now, it makes it a bit more fun than a paperwork exercise, and this reflects the AREA framework. So AREA stands for Anticipate, Reflect, Engage, and Act. So we want to anticipate the impacts, the unintended consequences, things that are beneficial that we might not foresee, as well as things that might be troubling. We then want to reflect. So what is the real purpose of the research? What is our motivation? What kinds of uncertainties do we have to deal with when we undertake a project? What are the assumptions that we're making? And where are the points where we might be ignorant to the impacts? And then we engage as a team. We engage in an inclusive way. And this might be, for example, debating a particular issue. And then we act. So we use this process to influence the trajectory of the research and how we perform the research. And I'm going to give you an example of this. So there's this problem that not all people can adequately express pain to their doctor. So some people might have a speech impairment, or they could be a stroke survivor. They might have cognitive difficulties. They could be children, and they're not accustomed to saying in an exact way that I'm in a certain amount of pain. Another issue is that someone could be a foreign language speaker visiting a country, and they just don't speak the language. They have no problem whatsoever, but they just have a language barrier. And so it's very difficult to say, I'm in pain. It's an 8 out of 10. So that's a problem we're looking at in the particular project that I work on. And what we're trying to do is come up with a proof of concept solution where we look for these acoustic biomarkers in the auditory signal that correspond to pain. We chose to do this in a cross-cultural pain expression study between the US and UK. And while I can appreciate that the US and UK both speak the same language, there are some cultural differences, especially around race is one example. And we want to develop an AI that can analyze pain from audio and compare that with a doctor assessment of pain to look at how doctors in the US might rate pain from people in the UK and how doctors in the UK might rate pain from people in the US. So this is an overview of the project. The first thing we have to do is collect data, and to do this, we have to induce pain on people. Now, originally, we were going to use a Tesla suit to control where in the body pain could be invoked. We ended up using a different protocol in the end. Then the second stage is to develop a system, an AI algorithm that can analyze the speech and detect pain levels from people from only their voice. So no video, no other sensors, just the voice itself. And then the final stage is a cross-cultural study with the US and UK doctors, where they're presented with a person speaking, and they must decide how much pain they are in. And then we can compare that with the pain that is reported from the person experiencing the pain. So in terms of responsible research innovation, is this a responsible project to carry out? There's a lot of issues here. So pain signals in speech could be used for torture or other nefarious applications, and it's something that we have to consider when we think about disseminating our research algorithms and research results. We absolutely have to have ethical approval in order to induce pain on people and collect their speech data. And in the UK, we have this GDPR, a General Data Protection Regulation, that says that speech is a special category of biometric information, so it's difficult to share. Then we also need a certain level of pain in order for it to show up in the speech data. If we don't induce enough pain, then there's not enough signal. And if we induce too much, then that is probably unethical. And then we have this issue of sharing the speech pain data across international borders. Even though US and UK are very friendly countries, it is still across border data sharing, and that is very complex in order to do that. And then there's this question of which pain level is actually the ground truth. Is it the amount of pain the researchers believe they are invoking? Is it the pain level that the person experiencing the pain decides they are in? Or is it the pain level that a doctor has assessed and decided that the person is in? In this project, we take the pain level ground truth to be what the person experiencing pain has reported. Pain is subjective, so everyone is different and everyone will experience pain differently. So one person's low pain level might be another person's high pain level. And then there's different types of pain. There's chronic pain, there's acute pain. In this study, we wanted to look at acute pain. So amazingly, this work was funded. The ethics was approved in both the US and UK. And we also had a paper accepted to Interspeech on this project. This is our team. So we had 3 universities involved with this, with 3 co-PIs and a core team of 10 people representing 7 different disciplines. I was the only speech researcher on the team, but we also had a legal scholar, psychologist, a surgeon, and human-computer interaction specialists, as well as responsible research innovation specialists. We had multiple undergraduate interns help us with the data collection and curation of the data set. Some of our early results that I can share here. Now, this is based on our pilot study in the UK. This has been accepted to Interspeech. So we had different types of pain. We had them report on a scale of 1 to 10, and then we classified that into either no pain, or a 3-class problem where we had mild, moderate, and severe pain. We used several different simple machine learning classifiers, so support vector machines, logistic regression, and multi-layer perceptron. And we saw that all of our classifiers performed above a random baseline in all of our prediction tasks. Most of our participants in this pilot study were female, so we weren't able to get a breakdown of male and female. So we report female and mixed on the table on the right-hand side. Then we used some explainable AI using Shapley values to see what kinds of features correspond to the pain. Now, this is ongoing work. So we used a principal component analysis to find some of the key features. We looked at open smile features in this and saw which features are contributing to the classification decisions the most. You can get more details of that in our inner speech paper. So what about AI regulation? It's a good question. So I'll present some of the vision of AI regulation from the UK's perspective. I'm actually not very familiar with AI regulation outside of the UK, but in the UK, we take what we call a pro-innovation approach. And the reason for this is that we don't want to hamper innovation, but there are some things that do need to be regulated. So some of the motivation behind this approach is to adapt and keep pace with rapid development. So startups, for example, are innovating, and we don't want to stop that innovation process. We want to have an ecosystem in the UK that is friendly for startups. And we don't want to have startups unnecessarily compete with the resources of big industry companies, because that would also hinder innovation, and only to regulate what is absolutely necessary. So they look at it from these 5 principles, the first one being safety, security, and robustness, followed by appropriate, transparency, and explainability, then fairness, accountability and governance, and contestability and redress. So that last one, contestability and redress, includes, for example, being able to remove your data from a large language model. A very tricky thing to do at present, but that is something that we're very interested in the future. So in terms of a roadmap and vision, what the UK would like to do, or what they are doing, is using their existing regulatory bodies to regulate AI in each sector with existing jurisdiction and powers. So, for example, we're not establishing a brand new AI regulator in the UK. It's a little different from what the EU is doing. Instead, the existing regulators will continue to regulate their own sector, and they will be upskilled. And there will be some cross-regulatory platforms. A great example of that is the Digital Regulation Cooperation Forum, which includes people like Ofcom and the Competition and Markets Authority, among many others. And that will allow them to share best practices, for example. And then there's this phased approach. So rather than rolling out brand new legislation and laws, they're doing a phased approach where the regulators give feedback and get feedback from DCIT, the Department of Science, Innovation, and Technology. So we're in phase 1 right now, and that's where regulators start considering the guidance from the government and develop what kinds of activities they want to do for the regulation of AI in each different sector. I guess I should also say by sector, I mean things like the aviation sector will have to deal with AI, the maritime sector will have to deal with AI. The most obvious probably for me working in speech technology is the communication sector, so things on the internet, things like that. So there's all these different sectors. And in phase 2, the government will receive the feedback from the regulator and clarify any issues. And then they will establish some joint tools for all of the regulators. And my involvement in this has included running some regulation workshops. So last year, we had our first AI regulation workshop in May 2023. And this is where we got a whole bunch of people together in one room. We had 45 attendees from universities as well as regulators and had invited talks from 6 different regulators. Those included the National Cybersecurity Center, National Highways, the government, Health and Safety Executive, Ofcom, and Competition and Markets Authority. And what we wanted to do was open up a conversation and normalize an interaction between academics and regulators. So we looked at 3 different kinds of sessions. One was problematizing. The second one was solutioneering within domain, so within a sector. And then the final one was looking across domains. So for example, what does aviation and communications sectors have in common? What are their common pain points? And so some of the key takeaways from this workshop was that the regulators need cross-collaboration and cross-regulation to solve some of their biggest problems. It won't help if they work entirely alone. They need each other. There's also a need for more evidence gathering and case studies. And then communication to the public beyond policy is really important because not everyone can digest a lengthy law or policy paper. So being able to communicate to the public what exactly we're doing or the UK government is doing is really important. We followed that with a second regulation workshop several months later in November. So this was very similar, except for this time, we also invited industry so that industry could have a voice in this. This workshop was a little bit bigger. We had 55 attendees, and again, 6 invited talks from UK regulators and academics. We included this time UK Parliament, Electoral Commission, the Military Aviation Authority, and a few others. It had a similar format, but this time we had different takeaways. So our first takeaway was that it is incredibly difficult to look at AI regulation across sectors because the needs in different sectors are very, very different. And different sectors have different appetites for AI regulation and different pressing issues. And what I mean by different appetites is that some sectors, like the financial sector, is very far along in algorithmic analysis and forecasting and things like that. So their appetite for AI is going to be very different from a sector who has never had to deal with AI before. And then we also found that the term safety critical systems will mean very different things to different regulators in terms of risk of harm. So the risk of harm of a plane coming out of the sky is a different kind of safety critical risk than pornography on the internet. Both can be considered safety critical. However, they're very different kinds of harm. And so when we talk about harm or mitigating harm, it's important to think about it in the context of a sector. All of these workshops led to a new project that I'm leading. Now, this is an international partnership with Australia and the USA. So I represent the United Kingdom. We have Zena Assad in Australia and Peng Wei in the US. I'm also running a volunteer internship with Southampton undergrads and some undergrads from the US at Tufts University. And we're looking at speech technology safety and doing a big deep dive there into deepfakes. So in this partnership, my main interest is in the communication sector because I work on speech technology, but there is overlap with aerospace and maritime. So we pick these 3 sectors as our safety critical sectors, and we are developing a toolkit for AI regulation safety assurance from an academic perspective that will be useful to regulators in each country. So to do this, we deep dive into specific technologies in the 3 sectors. We look at cross-regulation, and ultimately we try to identify the technical and regulatory gaps. And what I mean by that are places of innovation that researchers like us in academia could work on to help close some of the technical gaps for regulators. The way this project is set up is that we have the core team, and that's the 3 people that I had on the previous slide. And then we have this engagement model where we have our advisors and our extended network. And then we will run workshops in each of the 3 countries where we engage with our advisory network and our extended network. So the advisory network helps us pinpoint exactly what kinds of case studies that we should be analyzing and some of the regulatory challenges in the sectors. The extended network will help us deep dive into the safety critical factors for the case studies, identify the technical, socio-technical, social, regulatory, and standards gaps. And then as a core team, we'll come back and come together and start looking across our nations to see, are there any common elements for a toolkit that we can develop? So some of the outputs will be, for example, a regulation toolkit, summaries of our workshop, academic publications, and some ideas for applying for follow-on funding. So now I'll talk a bit about some insights from the SPSC-SIG that I'm currently chair of. So this is our SIG. I work with Ingo Siegert in Germany, and that anyone could join the SIG, by the way, if you'd like to. You can join our mailing list. We are running a workshop in Coast, Greece, as part of InterSpeech 2024. You're welcome to register and attend that if you'd like. And we're co-organizing that with the Voice Privacy Challenge this year. We also have a special issue in computer speech and language. So if you would like to submit an extended write-up of a paper, you can submit that into our special issue to this journal, and the deadline is August 5th. As a SIG, we have monthly webinar series, and that is open to everyone. So PhD students, master students, postdocs, professors, industry professionals, anyone who's interested in security and privacy in speech. We had an event a couple months ago where we got together and we tried to prioritize some of the speech technology areas that we think would require the most regulation. We did three tasks as a group. We did first a bottom-up imaginative hierarchy of issues. So this one had no structure, and we just started putting together notes. That's the very left-hand side you see on the page here. Putting together some notes of what we think are some of the issues and how different issues might be related. Then we group them based on the priority, so urgent issues, secondary issues, and tertiary issues. And what we came up with when we stand back and look at the themes, there are some technical considerations. We also need to improve how we communicate to stakeholders. Now, stakeholders can be anyone. In the beginning of this presentation, I listed some of the stakeholders. So the general public is one, but also regulators, standards bodies, other academics who may be outside of our discipline, anyone who might have an interest in voice privacy or protecting people's identity. We also had a theme called data issues. So how data is made private in order to share, for example, sharing data across borders or internationally. And then we also had the final category, bias, transparency, and fairness, and how we can try to come up with metrics for those topics. Then we looked at some cross-discipline issues. Now, for this, we looked at what are some of the more obvious disciplines or sectors that voice privacy can impact, and then what are those impacts? And we came up with health. So any kind of health data that is voice data will require some form of privacy protection. Fairness and diversity in the legal domain. So for example, being able to make claims in a legal court in a way that jurors or a judge could understand it, because a lot of the work we do is technical. So being able to communicate that to a non-technical audience. Any kind of video processing, that also came up. So video processing is of course, a technical area, but video can have speech data in it as well. Then we have the issue of usability for usable security and privacy. Can it be controllable? Can people decide what levels of privacy they want over their speech data? And what kind of technical challenges do we need to overcome in order to offer that kind of privacy to people? And then in the education sector as well. So things like engagement monitoring or adapting online lectures to people with disability. In terms of our urgent areas, we identified that voice privacy in the context of large language models is something that we need to be thinking about within the SIG. Preventing voice data from being used to create a deepfake. So right now we see a proliferation of deepfakes. This is affecting pretty much everyone around the globe, especially in the context of elections, but even outside of elections, this is a big issue. So we're looking at how can voice data be protected in a way that it cannot be used to train or create a deepfake. And then looking at a full pipeline of data provenance. So data provenance is another word for where does the data really come from? When we train, for example, a large language model, did anyone consent for their data to be included in that model training? And are there ways that we can have blacklisting tools to accept data from being used for training? And then regulating privacy requires quantification of privacy. This was a major theme in our session. So being able to have these comprehensive data sets and metrics that we currently are missing. This includes designing data sets in a way that allows us to get very good real world reflection of privacy. And then we need metrics, more metrics that can allow us to verify what kind of privacy we have achieved. And then we have, of course, empirical metrics versus formal privacy guarantees. What we often do in academia is an empirical analysis, and we measure something. That's a little different from a formal privacy guarantee, which may be something more likened to the legal domain, where things are more absolute. It's either private or it's not. There's no gray areas. We're also looking at voice-related copyright and ownership to a legal standard, and addressing whether and how speech technology regulations are distinct from other AI domains. So this ties back into some of the AI regulation workshops that I talked about earlier, where different domains, different sectors are going to have their own kind of regulations, and this will vary from jurisdiction to jurisdiction. So how the EU does it is different from how the UK does it, and it's different from how the US and other countries are doing it. So when we talk about voice privacy and speech regulation, we're curious to find out kind of how that will be distinct from other types of AI regulation. So towards this effort, we had a paper in ICASP this year where we were looking at anonymizing voices and whether or not they are easy to imitate or difficult to recognize. So I'm giving here just like a really high-level overview of that paper. You could read the paper if you're curious to get the details. But basically, we're looking at some speakers' voices are inherently more difficult to anonymize than others. And we classified them into 4 categories, which follow from these animal categories: sheep, goat, lamb, and wolf. Now, we did not create these categories. We actually took these from the speaker recognition domain from 1998. So this is sort of an idea from a different domain of speech technology that we're now applying to voice privacy. And they have different definitions. They have a mathematical definition, but I've left the maths off of this slide and just given more of a verbal explanation. So most speakers are sheep. They're sort of like the average type of speaker. They represent most of the population. Some are more difficult to recognize, like a goat or a wolf. And what we did in this paper is we looked at recognizing speakers from a human perspective using human A/B scoring, as well as from an automatic speaker verification perspective. And on the right-hand side, we can see our speakers on the x-axis and how their distribution of animal categories changes. So some speakers are all sheep all the time. They pose no inherent difficulty. Other speakers will have this distribution over the animal categories, and those speakers will perform differently in different anonymization systems. To go a little further, we looked at sort of the flow of what these categories look like across a set of 9 different anonymization systems from the Voice Privacy Challenge, including original speech. And we can see that the distributions change depending on whether a speaker is male or female, and also depending on whether or not we're using human scoring on the top or ASV scoring, automatic speaker verification scoring, on the bottom. So this has huge implications for how we design the data sets that we use to benchmark voice privacy systems. So getting sort of closer to wrapping up, what's next? So from my perspective, there are a lot of interdisciplinary shifts in speech technology. We are moving away from a lot of these cloud-based large models towards more edge device processing. So this is despite all this growing hype about large language models and foundation models. Really, the future is in edge device processing. Working on edge devices requires a really special skill set to be able to marry the software and the hardware aspects of doing speech processing on the edge. And this type of skill set is really difficult to find in academia. So if you are completing a PhD or a master's degree and you want to prepare yourself for a very exciting career, you can consider looking at edge device processing as part of your research to sort of prepare you for these industry jobs. we're seeing a lot more increased interest in medical applications of speech. So to be successful here requires an understanding of clinical context as well as the patient end users. And there's a significant increase in privacy. And this is due to a lot of push lately for regulation, protections, data protections, and things like that. So to be successful here, it requires innovation towards protecting sensitive aspects of speech data. Right now, there's been a lot of research on identity, but there's also interest in content, concealing prosody, concealing a person's medical conditions, their age, their gender, or changing their accent. And we also need more updates on standards. So that can include ISO standards, but really just any standards would be helpful. Legalistic definitions of human versus synthetic speech. This is going to be very important as we see more deepfakes enter the courtroom, where people may have a defense of the speech evidence presented in court is synthetic. It's a deepfake. I didn't really say that. So that's going to be more of an issue, as well as copyright protections on speech as it gets folded into these large language models and foundation models. So I think that is everything from me. Are there any questions?
Thank you so much, ma'am. Yeah. Go ahead. Sir.
Yeah, we can proceed.
I'll quickly ask the questions that we have on YouTube. So the first question is around how does AI regulation for speech is different from other modalities such as visual and text?
So the first thing that comes to mind, oh, sorry, we have an echo. There we go. Okay. The first thing that comes to mind is that speech is inherently a form of special category data under GDPR. Now, I know not every country uses GDPR, but some do, or some are looking at it. And that is because speech is a form of biometric information. So how you might protect a person's identity it can be very different than an image or video. So in an image or video, you can just blur the face or blur the eyes and you're good. And then you just have to track that as the image moves in a video. In speech, that information is deeply entangled into the other informational factors like the content or the prosody or whatever it is that a person's studying. So that's one way that it's technically different. It also seems to be, if I can say this, a bit mysterious for people. Not a lot of people, unfortunately, are comfortable with speech data because it's not something you can really see. And a lot of people miss it in the sense of they don't think about it. Like I speak, it goes into the air and it evaporates. It's non-persistent. Whereas an image, I can hold it, I can even touch it, it's something concrete. So it's easy to overlook speech in that sense. But looking at the link of speech regulation across different sectors is something that we're definitely interested in to see what we can draw from. If there's other regulations that just apply automatically to this domain, then that would save everyone a lot of time and energy.
Okay, ma'am. The second question is, recently there have been developments of language models such as DarkBird, which is pre-trained on dark web data. Is there a chance of developing speech models for pre-trained on dark web data?
On dark web data?
Yeah, because there was a development called DarkBird. So I think that's a large language model trained on dark web data. So could there be something similar for speech is the question.
Well, that's a really good question. I hadn't thought of the dark web for a very long time. I don't know much about the dark web, but I imagine if there is speech data there, that someone will want to use it somewhere for better or worse. Yeah, so my answer to that is probably yes. Whether or not that is desirable or responsible research innovation, and how that ties into AI safety is a whole different question that I don't think I personally could answer, but I think it's interesting for sure.
Ma'am, we have Hira sir on the call. He has raised a hand. It's actually his question on YouTube, so I'd like him to, maybe he has a further doubt, sir.
Hi Jennifer. Hi. We actually had a reading group like a couple of weeks back where we saw a paper on darknet. So it was trained on the darknet data, and I was just wondering, yeah. So we have like seen some recordings and some activities on the darknet on speech. I'm just wondering if there is a possibility of creation of speech models using those kind of data. I'll also share the link of the dark paper here so that you can also have a look at it.
Yeah, that's great. Yeah, I'll take a look at that. I don't know anything off the top of my head. I mean, some things you might want to do, depending again on kind of what you're up to on the dark web. You might want to identify the speaker. You may want to analyze the content of what they say. You may want to conceal the speaker identity. So that might be a privacy question. And yeah, it's a really interesting. I really genuinely haven't thought of the dark web, but I'll read the paper. Yeah.
Sure, good, thanks.
Then I'll go to the next question, ma'am. Is there any way regulations? Is there any way regulations which kind of data we should not use while building foundational models? So is there any regulation around what kind of data should not be used while building foundational models?
I think it depends a bit on what jurisdiction you're currently in, because different companies are having to abide by different rules as they roll out their models. So recently there's been that I only found out about this from friends who happen to live in different places in the world. The EU is requiring the companies like Meta to do something different with the data than the US is requiring. Yeah, I don't know any other way to opt out or control how that data goes into a large language model or a foundation model, unless it's within a particular jurisdiction. And then I don't know if there's technically a process yet. I don't think anyone has invented it on how to trace where that information propagates throughout a large language model, so that if someone wanted to delete their data, how that would possibly happen in a large model. So I'm not aware of any specific AI regulation about that, but I think the EU probably is eager to make that happen.
Okay, ma'am. And the next question is, can possible job loss from market due to AI ever be a consideration for AI regulators?
I think so. Absolutely. In the UK, because I can't really speak to other regulatory jurisdictions, but in the UK, I think the Competition and Markets Authority, that's something they think about, because they regulate markets. They also look at like how different providers for AI services can compete, because I think the idea is that a competitive market is a healthy market, so that there's no one company owning all the data and doing whatever they want with it. They want other companies to be able to compete, to offer different services to people. But I don't think that really gets at your question, which was how to prevent, I guess, AI from taking people's jobs, right?
Yes, I think that was the question.
Yeah. I imagine if you could raise it to a regulator, they could already be working on it, and I just am not aware of it. But yeah, I think in the UK, they're definitely considering like, how does ChatGPT really affect customer service, for example. If ChatGPT can answer all the questions, or any kind of chat system can answer all the questions, do you need customer service representatives on the phone when you can just chat with a bot? But we're seeing that there was a news article that I think came out of Canada in the last few months about a customer service chat bot giving incorrect information about a policy, and then the customer sued the airline for giving incorrect information. And so that's something everyone has to consider, is nothing can really replace a human. Even if it's a person auditing the conversations, nothing can really replace a human.
So the next question is, for the speakers who are easy to imitate, what acoustic markers represent that easiness? Maybe similar representation what voice cloning systems learn. And the part 2 of the question is, how do we define this easiness or hardness?
Yeah. So that is ongoing work. That is a work in progress that we hope to publish very soon. We are looking at sort of the interplay between a voice anonymization system and what those features are. And we're looking at a couple of different methods for how to identify the features of the speakers that we would call challenging. That is definitely an open question right now.
I think that answers all the questions. I don't see any more questions on the YouTube chat. So with that, Vidar sir or Sushi sir, anyone, do you have some further questions or any comments before we wrap up the talk?
Yeah, Jennifer, hello. So, yeah, it's an excellent session actually. So I think our audience got so many informations from your session. And one question I have is that regarding that easiness data, like how to imitate, whether we can imitate or not, easy to imitate or difficult to imitate, whether you are going to release that data after your work, or is there any chance of that?
We hope, yeah, we hope to release all the details for replication purposes. Yeah.
Okay. Okay, great. Yeah. Hridoy, are you having any questions?
No, I think it's a great talk. I think combining speech with privacy and security, I think it's something. I think it's very much important in today's era, and I think it's a great talk for the audience, like who wants to jump into speech and into security and privacy. So great. I think maybe you can conclude the talk now, and thanks again, Jennifer.
Thank you.
Okay, then thank you so much, ma'am. Yeah, with that, I think so we have come to the end of the talk, and I'd like to thank everyone who has been here on Google Meet as well as on the YouTube who have watched this talk. And I think it was the first talk we had on around AI safety, but it's going to be more and more important in the time to come. So, ma'am, we hope to have you again in the future very soon. And once again, thank you so much for this talk, and I hope to see everyone else in the next series, in the next lecture of our technical lecture series. Thank you. Ma'am, you'll just close the live stream.
Thank you. Yeah. Maybe you can close. So we'll stop the live streaming. Jennifer, like wait for maybe 1 or 2 minutes. So